This is take two. We just tried and got a ways, then everything quit on us, and hopefully we've got everything going now, so we'll quit this
Again.
time. We hope.
Fingers crossed.
Yeah.
Fingers crossed.
Jessica's got her fingers crossed back there. Today, in my time, is July 31st. You guys will be seeing this in October when I'm in Germany. Hopefully I will be coming back from Germany. We'll see. Related to rate problems, and Mrs. Bagman, please don't let them work on their homework until after we go to these problems. Make sure they're listening, and they can pick up something on how to do these problems. All right, first problem. The moped travels at 15 meters per second, and the bike goes 12 meters per second. The bike is 100 meters south of the corner, and it's headed north. Now you got to picture that. You got to be able to read that. We've got a corner. The bike is 100 meters south, and the bike then is going towards the corner. The moped is at the corner and is headed west. I didn't erase all this from our first take, if you want to get home sometime this night. So I drew my picture. Got quite a bit up there already. Okay, this would be the moped is heading west. Here's my corner. That's the C. Let me put this M out here for this moped heading that way. It's heading west. Okay, the bike is out here 100 meters south of the corner and is headed north. Okay, I'm labeling this as my X, this is my Y, this is my H for hypotenuse, of course. We're trying to find on this problem how the distance between them is changing at 5 seconds. How the distance is changing at 5 seconds. So in 5 seconds, if this moped is going 15 meters per second, in 5 seconds, that would be 75 meters. Okay, for the bicycle, it was out here 100 meters. The bicycle is going 12 meters per second. 12 meters per second for 5 seconds, that's 60 meters. The bike was out here 100 meters. It went 60 meters, so now it's 40 meters from the corner. Okay, a little Pythagorean theorem, 75 squared plus 40 squared should equal my hypotenuse squared, and trust me, we should get square root of 7,225. Jessica, you better check my math on that. Oh, never mind. Okay, we're trying to find how the hypotenuse is changing, and it's going to be changing with respect to time. dx dt, I want to find out x is changing with respect to time. X is getting bigger here. If I look back here, that's 15 meters per second, so that is with respect to time. It's 15 meters per second. X is getting bigger, so that's a positive 15. My y, on the other hand, y is getting smaller. My dy dt, that's a bicycle. This is meters per second, so that's with respect to time. Because y is getting smaller as the bicycle heads towards the corner, that's going to be a negative 12 for dy dt. Trying to find dh dt, so we need an equation. Fortunately, we have a right triangle, so Pythagorean theorem, x squared plus y squared equals my hypotenuse squared. Derivative 2x, this is with respect to time. You're not a t, so I need the dx dt. Derivative is 2y. You're not a t, so I need the dy dt. And derivative, Jessica, is this still working? Is it still working? Am I still on? Hey, testing. Yep, I'm still on. Okay, good. This is as far as we got last time. I didn't, and I wanted to erase it all, but Jessica says, no, we got to keep going.
I'm the positivity in this room.
Yep, okay. Well, come out and say hi then.
This guy knows what he's talking about.
Hey, thanks for the plug. Okay, and derivative here is 2h, and you're not a t, so I need the dh dt. I see lots of 2's in every equation, so let's do some canceling. I can divide that term by 2, that term by 2, and that term by 2, and now it's a simple substitution. My x for my picture is 75. My dx dt over here is a 15. My y from the picture was 40. My dy dt over here is a negative 12. My hypotenuse is that ugly square root of 7225. And dh dt. dh dt, that's what we don't know. That's why I write that down. I always want to write down what we don't know. Okay, now it's just a simple calculator problem. I would go parentheses if I'm punching this into my calculator. And go ahead and punch it into your calculator. You 6 seniors, maybe we'll have more than 6. I hope we better not have less than 6 of you sitting there. 75, or parentheses, 75 times 15 plus 40 times a negative 12, close it off in the parentheses. And then, of course, you divide by square root of 72.25. And I came up with dHdt being 7.588. Okay, and that's how the hypotenuse is changing with respect to time. That's how my hypotenuse is changing with respect to time. That is a positive number, so good answer then. The hypotenuse is increasing 7.88 meters per second. Okay, for this first problem. All right, I hope you don't have any questions on this first one, because I'm ready to go to the second problem. Quick erase job here. Don't stop. Still got more to go with this problem. Hopefully this erases well. Okay, the exact same problem, except now we're going to say at 10 seconds. How is the distance between them changing at 10 seconds? So I can draw my picture again. Okay, at 10 seconds this time. Let me move that X once. I like it in a little bit different spot. Okay, at 10 seconds. X is the moped. The moped's going 15 meters per second, so 10 times 15, that moped would be out there 150 meters. Okay, here's what's different on this one. Okay, the bike is going 12 meters per second, so 10 seconds, that'd be 120 meters. So now look at your picture. They told us in the original problem that the bike starts 100 meters south. Okay, and now it's going 10 times 12 is 120 meters. So that bike is actually up here, this way. If it went up 120, then this should be 20 meters right there. I'm going to change my 150 and my X around. I think I had them where I wanted them the first time. And the bicycle is going that way. That's going to be my Y. And of course, there's my hypotenuse again. The HDT is what we're trying to find. My X is getting bigger. The moped is going 15 meters per second. So that's going to be positive 15. This time my Y is getting bigger. At 10 seconds, that Y is getting bigger, so dy dt would be a positive 12. Okay, now it's exactly like the last problem. So you get this picture drawn up. Use Pythagorean theorem to find your hypotenuse. And you should be able to finish this problem easily. Dixie, can you pause my... Dixie, Dee Dee.
Mrs. Begman.
Yeah, Mrs. Begman, yeah. Thank you, Jessica. Yeah, Mrs. Begman, can you pause this for a second while they finish this problem? Okay, thank you, Mrs. Begeman. Hopefully they came up with square root of 22,900 for their hypotenuse. They did their x squared plus y squared equals hypotenuse squared, and then substituted these numbers in. Use a calculator to finish it. I came up with dHdt equaling 16.454. And Again, this is how the hypotenuse is changing with respect to time. This is a positive number, so that hypotenuse is increasing 16.44 meters per second. And that would be a good looking answer, increasing 16.454 meters per second. Next problem. Okay, this time I'm going to make this change. At 8 seconds, but the bike is not moving. 8 seconds and the bike is not moving. Okay, here we go again. There's the corner. Here's my bike. Not my bike, but their bike. It's down there 100 and he's not moving. The bike in the corner. Okay, the moped is moving. There's my X, there's my Y, there's my hypotenuse. 8 seconds. The moped is going 15 meters per second, so 8 times 15 would be 120. Then we're set up to go. Little Pythagorean theorem, 100 squared plus 120 squared equals that hypotenuse squared, and I came up with square root of 24,400. If you want to double check me, you can. I made mistakes before, you know, I might have made one here. Okay, we want to find again how that hypotenuse is changing with respect to time. Okay, dx dt. Is the moped moving? Ben, is the moped moving? Ben, where are you, Ben? Yeah, the moped's moving. He's going 15 meters per second, so that's how x is changing with respect to time. He's getting bigger, so that's a positive 15. Kyle, is the bike moving? Hope you looked at that right there. No, the bike is not moving. Bike's not moving, so I don't need anything there, unless you're Tanya Hageman and you want to put dy dt equals 0, but I think you're making extra work for yourself. Equation I need this time, Pythagorean theorem, x squared plus y squared equals hypotenuse squared. Kyle, you said that the bike was not moving, so I don't need this here. I don't need that variable if it's not moving. So instead of y squared, I can call that 100 squared. It's not moving, I can just put the 100 in there now. Okay, now I'm ready to take the derivative from here, so derivative would be a 2x. dx dt. Derivative of constant is 0, so that's gone. 2h. dh dt. I'll divide both sides by 2. Then you can substitute to finish your problem. Okay, Mrs. Begeman, you can hit pause, and when it looks like most of them are finished, then you can start it again. See if you can get the same answer I got. Hopefully I didn't do it wrong. Jessica, you're probably going to be pretty good at related rate problems again. It's all coming back, isn't it?
Mm-hmm. I'll be dreaming about them again.
Dreaming about them again? Did you 2 years ago?
I did.
2014? She dreamt about related rate problems. Okay, so your work should look something like this. And I came up with a hypotenuse is increasing 11.523 meters per second at that time. So the big thing on this one, if the bike is not moving, you don't need a variable there. Instead of putting y and taking your derivative, just go 100 squared. And derivative of that constant is 0, so that part is gone on our problem. Okay, one more problem to look at with these. Then we'll be done with this lesson. How's your football team been playing lately? Remember the Vikings 2 years ago drafted a wide receiver from Germany. I don't know if he's played yet. Hopefully he'll do something this year. Volleyball girls. Okay, next problem. How is the distance between them changing at 5 seconds? Seems like we did this already, except I'm going to put one more qualifier on there. If the bike is going south. The bike is going south this time. Well, we draw a picture. Here's the corner. Moped, he's been doing the same thing all the time. Remember the bike was out here 100, and now he's going south some more, so the bike's out there. In 5 seconds, 15 meters per second, that should be 75 meters per second. 5 seconds at 12 meters per second, that would be 60, but it was already out there 100. It's out there 100, it's going 60 more, so that's going to change that 100 into 160. Okay, you know how to finish it from here. Python, this will be my Y, this will be my H. Ms. Begman, if you could pause this again and wait till almost all of them are finished, then we'll take a look at their answers. I think after you get the picture drawn, then it's an easy problem to finish. I've left a couple steps out here where I use Pythagorean theorem to get this square root of 31,225. Hopefully you got that also. Okay, and then I should be putting here x squared plus y squared equals a hypotenuse squared, and then taking a derivative with respect to time. And after I do those two steps, then I would substitute these in. And then it's just using your calculator and dividing. And be careful, make sure you divide this whole thing by that square root of 31,225. So a good looking answer, what this means again, that's how the hypotenuse is changing with respect to time. That's a positive number. So that's hypotenuse should be increasing 17.232 meters per second at that time. Well, that's it for this lesson. Don't shut it off. Don't shut it off yet. Don't shut it off yet. Jessica, my producer's got how many minutes is it on? Am I over 20?
No, 18.
18 minutes, okay, just about the right time. You know, if I'm going to Germany, I've got to be exercising because we're going to be doing a lot of walking. I'm going to head out right now and do some exercise. Mrs. Bateman, don't shut it off. I should have said that earlier. Oh, here I am again. Going out for a little bike ride. Time to get some exercise now. Until next time, we'll see you. Hope none of my students runs me over. Bye.